Making custom robots and 3D printing using a CAD software and some design principles is a creative process. But sometimes it eats a lot of your time because of unorganized design process. So let me share my 5 steps whenever I work on designing of my robots for applications. The first one is build plate size. Let's look into it. So to understand the first requirement, let's take a look on this image, which is containing 3 different models of Ender 3, S1, S1 Pro and S1 Plus. The most important part here is the plate on which an object is produced. Its volume is 270 millimeters. These two have the same, the third one is different. I have produced this sketch and bodies. This is the size of an object you can print on the first 2 parts of Ender 3, or I should be saying volume that you can produce on an Ender 3, which is this one is quite big. Now if you produce something bigger than these on your printers, then you would be requiring some extra joining of the components and thinking about how to connect them properly, and that takes up a lot of time. Now once you have designed your robot according to the build plate dimensions, you start to put the components, and when the components are also placed, you bring in the actuators. This is a differential drive robot and it contains left and right actuator which are placed beneath the robot, as we can see, and size is same on the left and right, but the caster wheel is of different size, and we can see that caster wheel is quite small than the rear wheel, so we have to bring in a holder for the caster wheel. So this line is actually equivalent to this line, which means that all of the 3 wheels, the caster, the 2 rear, should be touching the ground exactly at the same time. For that you require such holders, and this keeps the robot to be balanced when driving. Otherwise things are going to fall forward from the front and it might put pressure on the caster wheel. Let's take a look on another example. Here in this differential drive robot, if I disable the components, motors are held at a certain height from the base. An extra body has been printed. The only reason is to keep them able to match the height for the caster wheel. When you have sketched and padded or extruded your base, you need to start putting the components. Now once the components are placed, you have to attach them, and if you can see here, components like the motor driver we have, the ESP32 that we have, contains holes in its structure that can be utilized to pin them into the body, as you can see. So what we do, we create the holes on our body which are utilized to hold all of these components. In our case, the motor driver, the ESP32, all of these are held onto the base with the help of holes, and these motors are also holded with the help of these motor holders. When we have placed the component and we want to stack up things on one another because we have some space, you can see here we have the power distribution circuit, but if I want to bring in the ESP32 on this certain height, I can put it by using standoffs, and I have space for that as well. So I will enable the standoffs, and these standoffs are not going to disturb this power distribution circuit, and also going to hold ESP32 with the help of these standoffs. And while I'm completing the design, I will create more standoffs for connecting the robot base with the cover, which are connected through the screws which hold them tightly. If we look at another robot, there are some motor drivers which have a lot of pins on the bottom side that we want to take care of, and we bring in these standoffs, small standoffs, to hold them up from the base, so the component is holded at a certain height and the pins don't touch the base and the circuit does not get short. Any work done on the basis of some principles and steps is time saving and more knowledgeable and makes you do efficient things. So when we are joining the 3D printed components based on the designs, it becomes really mesmerizing.